Hi, this is section 411 and it's problem number 5, and I'm not off to a great start because I already can't find my pin. Oh, here it is. Okay, we'll see if I can do it. All right, we have Calvin Butterball, chief mathematician for Fly-by-Night Aircraft Corporation. He was responsible for the mathematical analysis of the manufacturing of the company's two models of planes, the camel and the Sopwith hippopotamus. The camel and the hippo. Each department of Fly-by-Night has certain restrictions concerning the number of planes which can be manufactured per day. So let's look at it first of all. I don't know. First of all, let's think about it. Let's let H equal the number of hippo planes, okay? Hippos, and C equal the number of camels. And it doesn't matter which one is put on the x-axis and which one is on the y. It actually works out the same either way. It'll look a little different, but you know, it'll work out the same. All right, so production no more than 7 hippos. So hippos have to be less than or equal to 7. That's one of my restrictions. And no more than 11 camels. So camels have to be less than or equal to 11. Shipping no more than 12 planes total. So H plus C has to be less than or equal to 12 per day. The number of hippos manufactured per day must be no more than twice the number of camels. So the number of hippos, let's see, wait a minute. The number of hippos per day must be no more than, so if we say no more than 8, that means it has to be less than or equal to. Okay, so 8 has to be less than or equal to no more than twice the camels. That's another one of my restrictions. And what's the other one? You must use more than 1,000 man-hours of labor per day. And it takes 100 man-hours to manufacture each camel and 200 to manufacture the hippo. So 100 hours for each camel plus 200 for each hippo, and so the total number of man-hours has to be, you must use more than, it must be more than 1,000. Must be more than 1,000 per day. All right, I think that's it. That's all my restrictions. Camels and the hippos, write inequalities, expressing, we already did all that. Okay, so we've done A. Now B. Show the region on your graph in which the daily profit would be at least 3,000. How many hippos and camels must be produced to give the greatest feasible profit? Okay, so the first thing we really have to do is just go ahead and plot this on a coordinate plane. Let me do it down over here again. Did I mess up somehow? My pin's not working again. Come on. Uh-oh. There we go. Okay. Now can I move this up over here? 100C plus 200H is greater than 1,000. Let's do that over here. 100C plus 200 hippos per day has to be greater than 1,000. Okay. All right. Because then let me do this over here like this. This is going to be, it doesn't matter. It can be the hippos or the camels. Why don't we put, let's make this C, and we'll make this the number of hippos down over here. I don't know how the book did it, but you know, just to show you, it doesn't really matter. Okay, and let's see. This is 1 camel, 2 camels, 3, all right, 4, 5, 6, 7, 8, 9, etc. Okay, and the number of hippos: 1 hippo, 2 hippo planes, 3 hippo planes, 4, 5, we'll put a 5 right there just so we know, 6, 7, 8, and that's the number, this is the number of camels manufactured per day. Sopwith camels, you know, it's a type of Snoopy Sopwith planes, right? And this is the number of Sopwith hippos, hippo planes every day. All right, now, okay, the hippo has to be less than or equal to 7. So, or equal to, I think last time I forgot to dot one of my feasible regions and that messed me up. Ooh. So let's see, but it can be equal to, so let's do that. And it has to be less than or equal to 11 over here. So, ooh, 5, 6, 7, 8, 9, 10, 11. So if I come up over here, okay. Ooh, okay, and then less than or equal to, and we'll come, let's even just bring this up over here. Okay, so we can see it has to be in this range right here. Now let's see. C is on the y-axis, right? This is kind of the y-axis right here, and this is the x-axis over here, right? C is on the y-axis, so we're going to solve for C here, and let me do this even in pink or something, right? So C is going to be less than the opposite of H plus 12, like that, right? Just solving this, which is the same thing as saying that Y, okay, is going to be less than or equal to the opposite of X plus 12. If that helps, it's, you know, because C is on the y-axis and H is on the x-axis. So it's just in y equal form, right? Okay, we've got 12 here, so let's see, 5, 6, 7, 8, 9, 10, 11. Oh, I gotta come up one more. 12, it's right there. That's where the y-intercept is, and it's got a slope of -1. So let's see, down 1, 1, 1 over 1, and it's going to be less than or equal to, so it is a solid line, okay? So something like this is going to be another one of my boundaries, and it's less than, okay, so far, this is the feasible region right over here, okay? So far. Got it? All right, now let's do this last one right over here. H is less than or equal to twice C. So solving for C, C is going to be less than or equal to 1/2 H. I could really put a plus 0 right there, right? Or in other words, you know, it's going to be C is greater than or equal to 1/2 H, just switching it around, the form I like to look at a little bit better. And then in other words, Y is greater than or equal to 1/2 X, because the C is on the y-axis and the hippos are on the x. All right, so in other words, this is just the line going through the origin, right? Plus, you know, I could write it like this too, right? 1/2 X plus 0. It's going through the origin. It is going to be a solid line also, unless I just did something wrong. I thought something, that one's not a solid line. All right, everything else is. All right, so it's going to be a positive slope, so up 1 over 2, up 1 over 2, up 1 over 2, and there we go, like that, okay? There we go. All right, it's going to be greater than that, so now, that's my feasible region, okay? Now it's bounded by one more thing, this one right here, okay? So my last boundary is right here, and it's going to be this 100C plus 200H is greater than 100. So now I've got to solve this for C, which is really going to be like the y equal, right? Solving it there. So I'm going to get 100C is greater than -200H plus 1,000. Just bring in that 200, adding a -200H to both sides, right? And divide everything by 100, and I get C is greater than -2H plus 10. Look at that. That's not bad. I can plot that, right? It's going to have, and again, think of this as y is greater than -2x plus 10, right? So let's see, I'm going to come up here 5, 6, 7, 8, 9, 10 right here. And now this is a dotted line. You need to remember that. Oh, okay. And then we're going to come down to 1, 2, and over 1. 1, 2, and over 1. 1, 2, and over 1. All right. 1, 2, and oh, look at that. Okay. Okay, and we'll make a dotted line right here. That's, you know, pretty bad dotted line, but it's okay. It's okay. And it's going to be greater than that. All right, so here's my feasible region right here. Bam. Feasible region right there. That's what I can do. That's kind of cool. I mean, I like that. Look at that. You know, so let's just pick a point in my feasible region, like right here. You can't have a quarter of a plane, so I do have to stay with the integers, right? So I could do I could manufacture 5 hippos and 4 Sopwith camels every day. Or is that every day? Or is it every month? Per day. Per day. The number manufactured per day. Wow, you can make a whole plane in a day? I can't even imagine that. Anyway, 5 hippos and 4 camels in a day. That fits all my requirements. That's cool, isn't it? I think it is. All right, or I could do, if I do 3 hippos, I have to do 5 camels. You see, because it's 3, 5. 3 hippos, 5 camels. That's in my feasible region. All right, so hopefully all that makes sense. Now let's just see, did I answer all the questions? Probably not, because there probably has something to do with cost here. And so let's see what else we have. We have all of our, everything's, look, we have everything plotted in our feasible region, so I don't need any of that anymore, okay? So let me erase all that. All right, let me see what else I have now. How many, oh no, wait. If Fly-By-Night makes a profit of $300 per camel and $200 per hippo, show the region on your graph in which the daily profit would be at least $3,000. At least $3,000. Okay, so let's see what we mean by that. Okay, the profit would be, what did they say it is? $300 per camel, so $300 per camel plus, and $200 per hippo. $200 per hippo, and we want that profit to be at least 3,000. So we want the range where 3,000, at least that, so 3,000 is less than or equal to 300C plus 200H. Is that right? That's going to be the profit is greater than or equal to 3,000. So it's at least 3,000. Might be bigger than 3,000, but it's not less than 3,000. Because see, here's the profit. That's how much I'm going to make, and that's greater than or equal to 3,000. Right, so hopefully that makes sense. And now let's, wait a minute, I didn't like what I did there. Let me redo that. There we go. All right, now we're going to solve for C. What am I doing? Let's try that again. All right, we're going to solve for C. I want to get to pin. There we go. Solving this for C, we'll get 300C is greater than or equal to 3,000 minus 200H, right? And then now divide everything by 300. So C, again, I'm solving for C because C is the y-axis. It's really like I'm solving for y, right? It's greater than or equal to 3,000. It's 3,000, right? Minus 200H divided by 300. Okay, so I'll come up over here to keep going here. So C is going to be greater than or equal to 3,000 divided by 300, which is 10. 10, right? Minus, and then 200 divided by 300 is just going to be 2/3 H. So once again, I usually like to write it the other way. I could write it like this. C is greater than or equal to 10 minus 2/3 H, like that, right? Or I could write it like this. C is greater than or equal to negative 2/3 H plus 10, right? And now think of that C as the Y. Y is greater than or equal to negative 2/3 H. Oops, not H. 2/3 X plus 10. So again, just think of that C as a Y and the H as an X. All right. So now if I'm going to plot this, let me pick a different color here, like green. So let's see, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, right there. Okay. Right on the point right there. Not the feasible region because it's on the dotted line. But all right, so negative 2/3. So let's see, go down 2, 1, 2, and over 3. 1, 2, 3. There we go. All right. Don't do that. Down 2, 1, 2, and over 3. 1, 2, 3. All right, and then it can be greater than greater than or equal to. So the only way that can happen to get a profit greater than 3,000 is if it has to be in this region. It's a pretty narrow region. It has to be in that region right there. It has to be greater than. All right, so like maybe pick You know, there's a few different points here that would work. Like this one would work right here, right? Does that work? Is that a point? Can't have half a plane there. Oh, no, that one won't work. Hang on. Let's try. If I do one plane, if I do one hippo, I have to do... Oh, it's hard for me to see where that goes. Do you guys see where that goes? Let's see. That's 2, 2, 2. So 1, you know, 1, it looks like it would go right there. Like that point is in the feasible region, which would be 1 hippo, and it would be 5, 6, 7, 8, 9, 10. Yeah, like 1 hippo and 10 camels would work. That's in the feasible region. Let's see, if I do 2 hippos, can I do something there? Let's see. 2 hippos, 2 and up. Would I get one in the feasible region? Looks like it's just hard to see. Like right here? I think so. Like right there. That looks like that might work. Okay, because that looks like it's 2, and it looks like it's the point 2 hippos, and 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like 2 hippos and 9 camels would work too. That's also going to give you a profit of more than 3,000. And I don't know. We can put these numbers in to check it and see. Does that give me a profit of more than 3,000? You know, the profit is going to be this one here is hippos. So let's see, where's the, here it is right here. Here's profit. Okay, so it's going to be 300 times C plus 100 times H. So it's going to be 300 times C. C is 10. 300 times 10 plus 100 times H, which is 1 hippo. And so yeah, $3,100. That's going to give a profit of $3,100. 110. 1 hippo and 10 camels. If I do 2 hippos and 9 camels, that'll work too. Let's see. 9 camels, so 9, where's the profit? 9 camels, 9 times 300, 9 times 300, plus, and then 200 times, how many hippos? Just 2 hippos, 2 hippos, and so I get $3,100 too. This also gives a profit of $3,100, and this is going to give a profit of $3,100. All right, so now what does it say? What's the last thing? Camels should be produced per day. How many camels should be produced per day to give the greatest feasible profit? And what would this profit be? The greatest feasible profit is going to be if I take this green line and I slide it up as far as I can, and I think this is going to be the point right here. I hope you can see that if I slide it up. Let me do that in black or something. You know, right here. Do you see? Slide that green line. Just imagine it sliding up. If you could do this on your paper, just slide, and then that is definitely not a dotted line, so that's going to be the point right there. Looks like that point is 1. Looks like it's 1 hippo, and it looks like it's 5, 6, 7, 8, 9, 10, 11. Looks like it's 12. Oh no, it looks like it's 11. 11 camels. So 11 camels and 1 hippo is going to be my greatest profit right there. And what would the profit be? I don't know. Let's figure it out. It's going to be 11 camels. So 11 times 300 plus, and then 1 times, sorry, it's going to get loud here in just a minute, 1 times 200, right? Because the hippos are 200, yeah. So $3,500. That's going to be the place of the greatest profit, because $3,500 right there, right? $3,500 for one hippo and 11 camels. So I hope that helps. Okay.